Hi there folks, Root Beer here, starting part B on our 2010 Pascal paper with question number 11. Several three-legged tables and four-legged tables have a total of 23 legs. If there is more than one table of each type, so at least two four-legged tables, at least two three-legged tables, what is the number of three-legged tables? Okay. So, well, what can we do here? So I might give a name to the thing I'm looking to figure out. So maybe T is the number of three-legged tables. And maybe F is the number of four-legged tables. Okay, so each three-legged table has three legs. Each four-legged table has four legs. And so the sum here needs to be 23. Okay. But I know that T must be at least 2 and F must be at least 2. Right? Because we need to have more than one three-legged table, more than one four-legged table. And so this sort of accounts for a certain amount of legs here. I'm just going to see. This might not necessarily be the best way to write this out. But, okay, so then we could subtract 14 on both sides, and we'd get 9. So 9 needs to be some multiple of 3 plus some multiple of 4. Well, 9's quite nicely a multiple of 3, so it's just 3 times 3. So I could say something like, well, let's let f minus 2 be 0, and t minus 2 will be 3, and then we'll have 3 times 3 is 9. And 0 times 4 is 0. When we add those together, we get 9. So this would tell me that f is 2, which I don't actually care about, and t is 5. So our answer is going to be 5. There are 5 three-legged tables. Okay? And that's going to be, all the way at the end there, that's E. Now this isn't the only way to do the question. When I got to this stage and I set up what is called a Diophantine equation, I could have just sort of started making a chart. What could T be? Well, I could start at 2, 3, 4, 5, and ask myself, well, what could F be? So if T were 2, then I'd have 6 already here. And then we'd bring the 6 over to the other side, and we'd have F is 23 minus 3T over 4. So 23 minus 6 is 17. Divided by 4, that's not an integer. 23 minus, well, now if t is 3, we get 9. And 23 minus 9 is 14. Divide that by 4, well, that's not an integer. Same thing with 4. 24 minus 12 is 11. Divided by 4 doesn't work. 23 minus 15 divided by 4 does work, and that's 2. Okay, so that's another chart-based way if you didn't want to do this rearrangement here. And, you know, both of them are perfectly fine ways to do the question. And, yeah, that's all we got to say there. Up next will be question number 12 on our Pascal paper.